Today we are going to study about the concept of real depth and apparent depth of a tank. And in such discussion, we take an example of refraction of light in which the water tank appears shallower, means less deep than what it actually is. What is the reason behind it? Let us see the reason for the shallowness of the water tank is the diffraction of light. This is this is an account of refraction of light. On account of refraction of light. How refraction takes place in the case of the water tank? First of all, we think as surface of the top level of the water. Suppose we are having uppermost surface of the tank. Yes, X and Y is the surface of water, and just we draw a perpendicular, or we think of that the tank is filled with water. Tank is filled with water up to the bottom. We supposed to be the level of water inside it with the shaded lines. We think of the water level and how the bottom of the tank appears at less deep, how refraction of light takes place. We will draw here. So all the dotted lines are nothing but the level of water of the water tank. Now you see here, the bottom of the tank is just lower surface. We can show it by the shadow lines. Suppose we think of at any one point where we consider as real depth of the bottom, for which we think that x is the real depth of the tank, and it is at a point. Suppose we have chosen any one point O, and ray of light travels from the water medium to the air medium. So we just allow the light to move in the upward direction. Light is coming up and it is entering into the another medium. So this ray goes up in the rarer medium. A is the point on the surface of water, and ray of light when goes to the rarer medium up to the A dash point. And we should give the arrow sign that shows the direction of traveling of light from the water medium. Now another ray is also here. The point on the bottom of the tank from where the ray of light travels, we allow the light to any other point other than A. We think that the second point is the B. Light may goes to B point also. And once again we draw the normal at the point B. So such normal is shown by the dotted lines, and we have decided the point in B and in dash as a normal. Here we see that the angle of incidence made at the point O by the incident light travels in the direction O to A, goes up to the A dash point in the straightforward direction in the rarer medium. Water is taken as denser medium. Water, medium, and rarer medium where the observer size is there, because light travels from water medium to air medium. Rarer medium means here air medium. So it moves away from the normal. It moves away from the normal and goes to the observer eye up to the point C, where observer eye is there. The angle made at the point B with the normal is R, and angle made by the incident light inside the water medium is I. So in this case, we see that the angle of incidence inside the water medium is made by the light which is incident at the point B with a normal N, B, and S, and when it enters into the rarer medium, it moves away from the normal and enters into the observer's eye. What happens then? Observers observes that the ray of light is not coming from the actual point O, from the bottom of the tank, but it is coming from a new point where the image of the bottom is formed, and this very dotted line is the direction of light from where it is coming. This is the point I, where image of the point O is formed just above the actual position of the bottom. So it is the refraction taking place when the light travels from water medium to air medium such that the angle of refraction made at the point B becomes more than that of the angle of incidence inside the water medium, and observes that the ray of light is coming from a new point I, which is the image of the bottom point formed inside the water just above the actual position. This very position where the image of the actual point O is formed inside the water, observed from the top of the water surface xy, it is at a distance small y. We are writing for, and this very small y is called apparent depth. So we have seen here the A to O is the real depth. It is the real depth, and A to I is small y taken, and it is called apparent depth. Apparent depth. O is the point of the object inside water at the actual position. O is the point object at actual depth. At the actual depth. OA. Below the free surface. Below the free surface of water. Free surface of water. That is XY, shown in the figure in a tank. So how the water tank appears shallower? The reason is that image of the bottom of the water tank forms at the point I, which is the virtual positions of the bottom of the water tanks, and that is why it appears to be shallower. It is nothing but the refraction taking place when the water travels from water medium to the air medium, optically denser medium to rarer medium. Now comes we just comes to the point uh, in the diagram we have seen here how angle AOB is equal to angle OBN dash, which is inside the water, angle of incidence, and another angle which is made at the image point I, AIB, which is equal to the angle made by N, B, and C. This is the angle of diffraction. And in the diagram, we decide the triangle. The triangle is O, actual position, with the A where the light incidence from water, and B. So we see here in the diagram by taking care of the triangle OAB. So in the triangle OAB, we just made here for simplicity O, A, and B. So we see here that the I is here at O. And in this very triangle, we will take the sine of the I in this very triangle. Sine of angle of incidence. If sine is taken, we will write perpendicular by hypotenuse. So AB divided by OB. And this is taken as equation 1. Now another triangle we will once again decide between image point and A and B. So image point A and B is the angle where you just think of I is the point inside making angle at the B, and A, I makes angle R, and we will find in this triangle IAB. So this very triangle IAB give us the sine of angle of refraction, which is equal to AB by IB. In this way, we take it as equation 2. Because light is traveling from denser medium, as light is traveling from optically denser medium, that is water medium, to optically rarer medium, optically rarer medium, air medium, and we apply the rule for by dividing the equation 2 by equation 1, we can write for sin R by sin I. Light is traveling from water medium, so I is the angle inside the water medium. Sin R by sin R. This is equal to, putting the value from equation 2, AB by IB, and sin I is equal to AB by OB. And this is the value which is equal to the refractive index of water. Refractive index of water with respect to air. And we rewrite for cancelling the value AB, and we get the terms OB by IB, and take it is equation 3. When angles are so much small, B is very close to the point A. For very small angle, for very small angle, for very small angle, the point B is close to point A inside the water. So ultimately we write the refractive index of water with respect to the air as OA by IA, and this OA stand for the real depth and IA stand for apparent depth. And so we get the relation between the real depth and apparent depth, which is relating with the refractive index of water with respect to air. And we have seen that the bottom of the water tank appears to be less deep due to the refraction of light taking place.